Hey guys, today we are going to be doing notes for assignment number 3, and assignment number 3 is all about integers. So we're going to have an introduction to integers, and we're also going to talk about adding integers. So before we get into adding integers, let's make sure we all know what an integer is. So up until about 6th grade, you have only worked with whole numbers for the most part. So whole numbers would be 0, 1, 2, 3, and on up. No fractions, no decimals, all positive. Integers, on the other hand, would be those same whole numbers, so 0, 1, 2, 3, and on up, but it would also include the negative numbers like -1 and -2 and -3 and on down. So you can think about the numbers that you would see on a number line. Those would be your integers. So integers do not include decimals, and integers do not include fractions. Now it is possible to have negative decimals and negative fractions, but we are not going to get into that yet. All right, so next thing that I'd like to review with you is what are opposites? So opposites get often confused with absolute value, which we're getting ready to cover again. So the opposite of a -98 would just be what is the positive form of that, which would just be 98. And if you had a +5, the opposite would be a -5. So I think probably that's pretty easy for most people to understand. Technically, both of these numbers are the same distance from 0, like -98 would be 98 to the left of 0, +98 would be 98 places to the right of 0 on a number line. Now again, opposites often get confused with absolute value. So let's review absolute value. I'm sure you've talked about absolute value last year. So absolute value, they use the symbols, these two straight lines on either side of a number. Let's use -6. Now what absolute value is asking is, how far away is this number from 0 on a number line? And it doesn't matter if you're going to the right on the number line or to the left on a number line. So -6 is 6 places to the left of 0 on a number line. So the absolute value of -6 is 6. Absolute value of any number is going to be positive. So even if we had the absolute value of 4, it would still be 4. So that's where people get confused with opposites and absolute values, okay? So again, absolute value is always positive. And notice that my answer doesn't have the symbols around it anymore. The absolute value of 4 is just a 4. So you don't want to write the symbol, those straight lines around your number. So when you have integers, one thing that you should be able to do with integers is you should be able to compare integers. And when we compare any type of numbers, we use comparison symbols. And we're going to be using the greater than symbol, the less than symbol, or the equal symbol. Sorry, that's a little bit off my screen. Equal symbol, okay? And probably when you were learning about comparison symbols, your teacher taught you about like maybe a alligator or something, okay? My great drawing skills. But the alligator is going to eat the bigger thing. And that's what we want to think about when we're thinking about these integers. So if we had a -7 and we're comparing it to a 10, well, anytime you have a positive number and a negative number, the positive number is always going to be bigger. So -9 is less than 10. Let's say that we had two positive numbers. You all have done a lot of comparisons with those. Maybe we have 5 compared to 2. Well, 5 is greater than 2. Now, it does get a little tricky when you have two negative numbers. Maybe we have -20 compared to -12. Be very careful with these, okay? -20 is a smaller number than -12. -12 is going to be closer to that 0. So if you think about a number line, okay, and I'm not going to write all those numbers on there, but -12 would be around here, and -20 would be down here. The further you are to the right on a number line, the bigger you are. So -12 is definitely larger than -20. Another thing that you should be able to do is you should be able to order numbers. And whenever you're ordering numbers, no matter what kind of numbers they are, you need to make sure that you listen or you read the directions. So for these directions, for these orderings, we're going to do from least to greatest. And that's pretty normal, doing from least to greatest. But every now and then they throw you a curveball and they ask you to order from greatest to least. And if you're not reading the directions carefully, then there's some issues, right? Not that you don't know, you don't understand, it's just that you didn't read the directions. All right, so let's say that we have these integers here and we want to order them from least to greatest. So what I'm going to do is I'm going to first look for my negative numbers, because I know my negative numbers are going to be smaller than my positive numbers regardless. So now I can just concentrate on these three negative numbers. Again, when you're thinking about your negative numbers, the larger the absolute value, the smaller it actually is. So this negative 30 would be my smallest number here, and then my negative 15, and then my negative 5. So I think it's a good idea when you're ordering numbers to kind of mark them off after you use them. And that leaves me with these three positive numbers. So if I order these three positive numbers from least to greatest, it would be 10, 20, and 35. So again, my suggestion when ordering numbers is to kind of break them into two sections. Order your negative numbers and then order your positive numbers, okay? All right, let's start getting into, actually, I'm going to back up and I'm going to talk about how to evaluate. All right, so that is kind of a directional word on what to do. If you evaluate when x equals a negative 7, what we're going to be doing here is I'm going to give you an expression. Okay, an expression means it doesn't have an equal sign. I'm going to give you an expression like the absolute value of x. And what you're going to do here is you're going to substitute in this number for the x. And then you're going to figure out what it is. And that is evaluating. Okay, so it's just kind of a fancy name for it. So the absolute value of x would mean the absolute value of, if x is negative 7, the absolute value of negative 7. And then you're like, okay, well, what's the absolute value of negative 7? And remember, absolute value is always positive. So the absolute value of negative 7 is just a 7. All right, let's continue doing some practice with that. We're going to keep our x the same value at negative 7. So what if we had the absolute value of x plus 4? So again, I'm going to substitute the absolute value of negative 7 plus 4. Absolute value of negative 7 is positive 7 plus 4, and that would give me 11. All right. What if we had 6, and then right next to it, we have the absolute value of x. So what this is going to mean is 6 times whatever the absolute value of x is. So 6 times the absolute value of negative 7. Again, the absolute value of negative 7 is a positive 7. So we're going to be doing 6 times 7, which is 42. And let's do one more. What if we had the absolute value of a negative x? So inside of here, this is going to be a negative 7. Now, if you remember, I said that absolute value is always positive no matter what. So even if you were like, if you didn't remember what to do here, well, it should just be 7, okay? But let's talk about really why. Hopefully you remember that if you have two negatives right next to each other like this, that's then going to become a positive. So a negative 7 is a positive 7, and the absolute value of 7 is 7. Lots of 7s there. All right, now let's start getting into adding integers. So hopefully last year when you were in Miss Knight's class, you all did talk about adding integers. And Miss Knight, by chance, she might have said same sign, sum, same sign. I hear that all the time when kids come into my class, they like saying it, same sign, sum, same sign. And it took me a long time to even remember what they were saying. I like a little song called, or it goes to the tune of Row, Row, Row Your Boat. And the song goes, same sign, add and keep, different sign, subtract. Take the sign of the higher number, then you'll be exact. So maybe that little song will help you. I honestly just prefer the rules. Okay, so let's talk about the rules. The rules. If you have the same sign, okay, same sign. So they're both positive or they're both negative. You are going to first add the absolute value. So So again, add the absolute values, and then you're going to keep the same sign. Remember, these notes will be posted as a PDF as well, okay? So again, add the absolute values and then keep the same sign. So if we had a very common problem like 3 plus 5, okay? Same sign, they're both positive numbers. Add the absolute values, keep the same sign. So they're both positive, so your answer is positive, all right? You learned how to do that in what, kindergarten? All right, this works the same way though if you have two negative numbers. Let's say we have -2 plus a -4. Now notice in this one that there are parentheses here. The parentheses are only here because we are separating that negative sign from this plus sign. I always kind of make the joke that signs will get into fights if they're right up next to each other, so we have to separate them so they don't get into a fight. So again, that's the only reason those parentheses are there, is to separate the plus from the negative. So I have a -2 and I have a -4. So same signs. I'm going to add the absolute values. 2 plus 4 is 6. And then I'm going to keep the same sign. Since they're both negative, then my answer is negative. All right, let's talk about what would happen if you had different signs, okay? Different signs. Now this rule is not quite as easy. Different signs. So the first thing that you would want to do is you would want to subtract the absolute values. And you always want to do the big absolute value minus the small absolute value, okay? So, and I kind of try to remember or remind people that if we're talking about subtraction, the answer to a subtraction problem is the difference. So different sign, subtraction, maybe you can remember it that way. And then once you have subtracted the absolute values, you decide if it's positive, the answer is positive or negative by looking at the larger number's sign. So whatever absolute value is larger, you use its original sign. So use larger absolute values sign. Okay, so again, subtracting the absolute values, then using the larger absolute values sign. So let's do some practice with that. Let's say we have a -5 plus 2. So again, we have a negative and we have a positive, so different signs. First thing I'm going to do is think about my absolute values, 5 and 2, and subtract my absolute values. 5 minus 2 is 3. Then I'm going to say, all right, which absolute value is the biggest? 5. Is the 5 in my original problem positive or negative? It's negative. So that means my answer has to be negative. Okay, so walking through that again, different signs. So subtracting the absolute values, 5 minus 2 is 3. Then thinking about what's my largest absolute value, which is the 5. And in the original problem, the 5 was a negative, so that means my answer has to be negative. If you can think about it as you owe someone $5, you pay them back $2, now you still owe them $3. All right, let's do another one. Let's say we have -3 plus 8. -3 plus 8. So again, different signs. We're going to subtract the absolute values. You want to do the bigger absolute value minus the smaller absolute value. And eventually you'll be able to do this in your head. Some of you might already be there. So 8 minus 3 is 5. And then we're going to be using the larger absolute value, which is the 8. We're going to be using its sign in the original problem. The 8 was positive, so that means this is a positive 5. Again, think about money. You owe someone $3, you make $8. You got to pay back that person you owe $3 to, and now you're left with $5. All right, let's do another example. Let's say we have 4 plus a -1. Now remember, the parentheses are there because we're separating the negative sign from this positive sign. So subtracting the absolute values, 4 minus 1 is 3. And then my larger absolute value is the 4. And in the problem, it was a positive 4. So that means it's a positive 3. And my last example here with these smaller numbers, let's say we have 6 plus a -9. 6 plus a -9. So I'm going to subtract my absolute values. 9 minus 6 is 3. My 9 is my larger absolute value, but in the original problem, the 9 was negative. So I'm going to have my answer as a negative 3. You have $6. You spend $9. Now you owe somebody $3. Now these rules work the same. Even if you have larger numbers, you just have to think a little bit harder. Okay, you can't do that subtraction or addition in your head necessarily. Let's say we had negative 54 plus negative 28. All right, so I always ask myself, I start off by asking myself, are my signs the same or are they different? And these have the same sign. They're both negative. So I'm going to remember my rule. Same sign, add. So I'm going to add my absolute values. 54 plus 28. That gives me 82. Same sign, add, and keep the same sign. So because they're both negative, that means my answer is going to be a negative 82. What if we had 38 plus a negative 17? So these have different signs. Different signs, subtract the absolute values. 38 minus 17 is 21. And take the sign of the higher absolute value. So the bigger absolute value was my 38. And in my problem, the 38 was positive. That means my answer is going to be positive. And let's do one more. Let's say we have negative 41 plus 26. Signs the same or different? The signs are different. For different signs, we subtract the absolute values. That's going to give me 15. And then we're going to take the larger absolute value sign. The bigger absolute value was the 41. And in the original problem, the 41 was negative. So my answer is going to be a negative 15. All right, that's all for this assignment. Next time, we will get into where you have more than 2 integers in a problem. And we'll also start talking about what do you do if you need to subtract.